Hey guys, I hope you had a great long weekend. Today we're going to continue looking at function basics and discover how to find inverses of functions algebraically. I sent you a lot of files. I sent you a lot of files before our long weekend. And so today you want to open the one called Finding Inverses Algebraically. We're going to start taking some notes on the Inspire. We won't do this all the time, but it's a nice change of pace. And some people prefer having all their notes on their Inspire versus some on paper. So it's just, trying to make everybody happy. So here we go. If you go to page 1-2 of that document, I want you to think about what word you think of, or what phrase or anything you think of when you hear that word inverse. What does inverse mean to you, whether it's in math or not? Take a minute to do that. And then go to page 1-3. So many functions have inverses. We'll learn how to find them algebraically today and graphically tomorrow. And then we'll also talk about which kinds of functions actually have inverses, because not every function does. Okay, so we have steps for finding inverses. Again, I'm going to type these today. You will probably also want to copy them into your cumulative notebook. So the first step for finding an inverse algebraically is if you see f of x, replace it with y. Then you're going to switch x and y, and that is our critical step. We switch x and y. Anytime you hear the word inverse, you think switch x and y. Then you solve for y, and you rewrite your new function using inverse notation. This right here, f to the negative 1 of x, means the inverse of f of x. It does not mean to flip a fraction or anything like that, which sometimes I know negative exponents mean. But a negative 1 attached to f of x means inverse of the function f. Okay, next page. 1-5. So you're gonna notice on your notes for the rest of this, there are examples to do. You can type through the steps if you'd like. I prefer to do these on paper, again, because then I'll have them in my cumulative notebook. So you'll see me switching back and forth between writing and the actual question on the Inspire. Okay, so to find the inverse of f of x equals 2x plus 1, we'll just talk through the steps. The first step is to replace function notation with y. So I'm going to rename this y equals 2x plus 1. Sometimes you'll already have y and you won't need to do that. Then you're going to switch x and y because it's an inverse. So I'm going to replace y with x, and I'm going to replace x with y. And then we're going to solve for y. We're going to get y alone. So subtract 1 from both sides, and then divide by 2. So y is x minus 1 over 2, but the last step is to use inverse notation. So this is the function f. Its inverse is x minus 1 over 2. And really, that's it. So let's look at a couple more. To use a function named g, whose rule is 1/3 x plus 1. And we're going to find its inverse. So here we go. The first thing we do is replace our inverse notation, or function notation, with y. So g of x becomes y. Switch x and y. So x equals 1/3 y plus 1. Now we're going to solve for y, get y by itself. So I'm going to subtract 1 from both sides. And this is 1/3 times y. To make a fraction go away in any equation, you multiply everything through by the common denominator. So here I'm going to multiply through by 3. When I multiply 1/3 by 3, it goes away. And then I'm going to take x minus 1 and multiply it by 3. There is no need to distribute. You can if you really, really want to, but you don't have to. So the final step, write this in inverse notation. The name of the function was g, so the inverse of g of x is 3 times x minus 1. Okay, let's see what's next. On page 1-7, you're given a bunch of points. So you're just given 0, 8, 1, 7, 2, 6, 3, 5, and 4, 4. I'm not going to write this one. We're going to type this because to find the inverse, again, you're just going to switch x and y. This is not an equation. It's just a set of points. So you just switch all those coordinate values. X becomes y, and y becomes x. So here I can say the inverse of h of x equals the set of numbers, and just start switching your x's and y's. So 0, 8 becomes 8, 0. 1, 7 becomes 7, 1. 2, 6, 6, 2. 3, 5, 5, 3. And 4, 4, 4, 4. So functions literally, inverses of functions literally switch x and y. That's it when you have ordered pairs. Okay, on page 1-8, we have one last equation to find the inverse of. And again, this is one that I will write. So we're going to find the inverse of f of x, which is x plus 1 all squared minus 4. So, replace f of x with y. Switch x and y. Get y alone. Now y is buried, and to undo that last, I can add 4 first. Now I undo squaring by square rooting, so I square root both sides. That cancels that squared out. So the square root of x plus 4 equals y plus 1. And then finally, to get y alone, I subtract 1. So the square root of x plus 4 minus 1 equals y. Because minus 1 is obviously not under the square root symbol. Inverse notation, inverse of f of x is the square root of x plus 4 minus 1. And you are all set. What's really nice about this is when we start graphing transformations, you'll really see what's going on with these inverses as well. Okay, that's it. Have a great night.